have the diagram below shows two quadrilaterals, R and S, where S is the image of R. S is the image of R. On the transformation, S is the image of R. So R is the original. Cool. The world I'm looking is bigger, so it's an enlargement for sure. Beautiful choice. Um, in this particular, well, if you talk about construction, for construction stuff, you are not allowed to use the protractor to draw anything, to draw your angles. You could use the protractor to measure and see if you did your your construction correctly, right? But if you're talking about to measure from like the North Pole to measure the angle, yeah, from the north line you can measure like that. But you don't use the protractor in construction questions to draw the angle line. You only use it to double check and measure to see if you drew the angle using the compass correctly. Yeah. Yes. Okay. Um, yes, you're welcome. So this here is an enlargement for sure. So what I'll do based on what I told you, I'll send you all the recording I uploaded from about a year or so ago. So you all could look and see how the construction is done, so you know to construct the different angles and stuff. But I will still do this question above the most likely I'll try to do later, but if that don't work out, tomorrow morning for sure. Morning because evenings can be interesting. So we have described fully the single transformation that maps quadrilateral R onto quadrilateral S. It is an enlargement for sure, because enlargement is when either one shape gets bigger or smaller than the other. But that's not all we need to say, you know, they said describe it fully. We need to figure out the scale factor, like how much bigger did S get from R? So in order to do that, we can use what is known as a scale factor formula. Scale factor. With scale factor, all you need to do, you take the image length, like one side of the image divided by the same corresponding side of the object. So for instance, I will take for the image and the object, the same corresponding side means the same side, the side that is, what's the word I'm looking for, boy? Position the same way. So these two sides are corresponding, right? They're in the same position, just on the different image object. So using the y-axis, the vertical axis, this axis over here, right? Why am I using that axis? Because these lines are vertical, just like the y-axis. So to measure, I'll start from here. This one started from 1, so you really have to count it as 0. So from here to here, that's like 0 to 1, 1 to 2, up to 3, right? So you can't check it as 4 because the diagram didn't start down here. It started above 0. It started from 1. So you have to count 1 as from 0, 1, 2, 3. So for the object, I got 3 units.
Yeah,
Mm-hmm.
yeah. Mhm.
Am I speaking to me? Or okay. And then this one start from -5, but you have to start and count it as if it's 0. So from here to here is 1, right? If you go from here to there's 1, so that means from 0 to here is 1. Going up again, 2. Going up again, 3. Going up again, 4, 5, and 6. So Yeah, 65 by 3 is 2, so the scale factor is 2. What does that mean? It means that the image S is twice the size of the object R. So we know it's an enlargement. We know the scale factor is 2, which means the image is twice the size of the original. One other thing we need to know, because the question is for 3 marks, um, we need to figure out the center of enlargement. The center of enlargement, all you really have to do on this diagram is draw some lines through corresponding vertices. I say, what? Okay, to make it make more sense, I am going to label the diagrams. So since it said R is the original object, I'll put here as A, and that same point in its image will be A prime. I'll put here as B, the same corresponding point will be B prime in the other one. This would be C, the same point down here will be C prime. Here will be D, and here will be D prime. So it makes it easier to kind of explain by labeling the vertices. So now I'm going to take, you all can take a ruler in the exam and do this, right, with a pencil. Don't use pen and thing for diagrams, yeah? Use pencil and stuff for diagram. Use pen for only writing like your actual like other working like what we did before. But anything that has to do with drawing and like a graph, use pencil. Everything else that is not drawing or constructing and stuff, use pen. Because I think in my whole life of teacher, I think last year I had a student who did their entire exam with pencil. Good thing CXC didn't penalize them for it, but you're not supposed to be writing all your answers on pencil. That's primary school stuff. Okay, so starting from this point, we're going to draw a line that passes through A, right, from A prime, but we want to draw it as far as possible. And the reason why, we need the lines that we are drawing to intersect. All the lines that we're drawing must intersect at the same exact position. So you have to draw it as far as possible. Okay. So same thing I'm going to do from B prime to B and continue going. Oh, sorry. That line started to bend there. Go all the way up. You'll see how the lines are starting to touch each other. That's what we need. That will help us figure out where the center of enlargement is. Same thing, we go with C prime. Sorry. From C prime to C. C prime to C is like there. Okay, so it looks like the center of enlargement is all the way down. So these lines are a little bit too thick, you know, I should have used thinner lines. And from D prime to D, and we need to intersect the other lines. Okay, so apparently it looks like the center of enlargement. The center of enlargement is where all the lines intersect. So it's somewhere around here, right? We work with it as somewhere there. So the center of enlargement, if you're wondering what is that, it means like the point from which the diagram enlarges from, right? Gets bigger from. So if you look closer to the point, it has a smaller space, but as it goes out and out and out here, it gets bigger and bigger. So based on the x-axis, the x is 3, the y is 7. So apparently the center of enlargement is going to be 3, 7. We always put x before y, right? 3 is x, 7 is y. So that's what we needed there. So final answer would look like, for what they want over here is describe the transformation fully. It's definitely an enlargement. Enlargement with this thing giving me trouble of a sudden. With center, the center is 3,7 and scale factor. And the scale factor, or you could put it as SF, is short for scale factor, is 2. Once you have that, you get 3 marks. Okay, hope you all got that there. The next part says on the grid on page 12, which is the previous page or the same grid page, the graph page, draw the image of the quadrilateral R when it is translated by the vector -4, 5. So we have a translation of R to do, right? So we translate in R. What else? It said name it T. Okay, we going from R to T, right? So we put it as like double prime or something. And it says on the grid, just looking at the other part one time. On the grid on page 12, draw the image of the quadrilateral R again was rotated 180 degrees above the origin. Name it M. Okay, so we have a translation and a rotation.
Excuse me,
Uh-huh.
when you're doing this, when you're doing this to show us how to do it, right? On the image itself, can you show
Mhm.
us how can we make those same images for them to see? Because it's one graph they're giving you, and they're asking you to draw all these things on one graph. So how to differentiate well, 1, 2, and 3 on the graph?
1, 2, and 3.
Yeah, because
I
you're
try.
drawing on the graph. You're drawing on the graph. Remember that you need to draw a grid or draw the image quadrilateral R on the same image you now give you on the 12, on page 12.
Mm-hmm.
So how to
Mm-hmm.
differentiate the difference? Because if they're marking you on it, how they will realize which one is which and which one is what? How do we
That is
number
why.
them?
So that is why over here, Ophelia, it said for this part, when we do the translation, you are going to put letter T for the translated image. So once you
No,
do the
but I understand that part. I understand that part. But talking about like when you draw any line, right? Remember the intersecting on each other's. They will
mm-hmm.
be intersected. Because look, the enlargement one on already one over to either one of the sides, that could be M or T, two or prime, whatever it's called.
Well, remember they already give us the enlarged diagrams, right? If it is you are
Mm-hmm.
asking about figure where to draw the lines for the enlargement or to find the point, the center point of the enlargement, I don't know if it's that you're asking. Because I know you said 1, 2, 3, so I'm still not 100% clear on
Right.
your question.
Like just now when you do all the lines to get the center, right?
Mm-hmm.
You do that to show how you get the center. Yes,
Mm-hmm.
leave up those lines or you erase those lines after. So when you're doing the other graphs, when they tell you to draw the T one or the M.
No, you need to leave it. You'll need to leave the line to show everything.
Right. So the what I'm trying to ask now, when you do the lines there, how to differentiate which line is for which answer?
They would know. The only time you do lines like that is only for enlargement. The other
Okay.
ones, which is translation, rotation, reflection, you don't have to put any lines like that at all. So only for enlargement, you have lines like those. Well, anytime they need the center of enlargement, that is. So when they said to describe the transformation, I knew for sure I had to figure out the center of enlargement. So hence, those lines were drawn. But if they didn't ask anything about the center of enlargement, you don't have to draw. Well, they didn't directly ask for it. But in this case, if they said to fully describe, I know that the image and the object is two different sizes. Yeah, the center has to be identified. I hope that answered your question, Ophelia. If
Yes,
not,
Tina.
okay, great. So they said to take R and translate it to T. Okay, so on a graph like this, we have R over here, right? I hope, because I know it's been a while we have done transformation, right? The first number is for X, the second is always for Y. When X is negative, you go left. If X is positive, you go right. When Y is positive, you go up. If the Y value was negative, you go down. So, just to make it easier to explain, I'm going to put back here A, B, C, D. So we have to move these 4 points, move all of them 4 places to the left, 5 places up. So starting with A, so we're going, this is 1, this is 2, 3, oh my, 4. 4 to the left, and then we're going up 5, 1, 2, 3, 4, 5. So that means the translated point will be up here for A, that is. Okay, so I'll just call it A prime just for now. I'll remove it because you don't have to put that. I'm just putting that for you to see what I'm doing and kind of make sense out of it. Same thing we're doing for B. We're going 4 to the left, 5 up. 1, 2, 3, 4. 5 up. 1, 2, 3, 4, 5. So we're calling that B prime. Going again, this time with C. So 1, 2, 3, 4. Going up 1, 2, 3, 4, 5. So that is where C prime that I labeled C before. The final one to do for this translated diagram is the one I labeled as D. So 4 to the left, 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5. All right, so I can move these lines because I just put them to translate. So when you do translation, you could move the lines. But as Ophelia was asking for the previous one, which was enlargement, you need to leave the lines on the diagram itself. Well, yeah. So I can remove these, and we're just going to connect the dots with straight lines. So connecting here to here, there, here, and there. And here we have, they told us to label this as T. So this is image T, which represents a translation or a slide of R. Okay. Okay. So again, if you have questions, you know what to do. Make sure and ask your questions where necessary. So there's one more to do. They said to rotate. But the funny thing to me, they didn't tell us where to rotate this, Them just say rotate. Like what? I didn't see whether to rotate it clockwise or anti-clockwise. But the only good thing, the only sense it's going to make here is this, right? Let me tell you what sense it will make. If we're moving 180, regardless if we go clockwise or anti-clockwise, you end up on the same spot. Yeah. So that's the reason why they didn't tell us if it's clockwise or anti-clockwise. But that is so, some students might have been like, what? But I know if it is, I moved it anti-clockwise. If I go from this quadrant, right? This is the first quadrant to the second quadrant is here. This is 90 degrees. right? And then if I go from the second quadrant to the third quadrant, that will give me a total of 180 degrees, what they're asking for to rotate it. Now, if I, instead of going anti-clockwise, I am going clockwise, I'll still land in the same third quadrant. How do I know? So if I go from quadrant 1 to quadrant 4, this is a fourth quadrant, this will be 90 degrees. Then from quadrant 4 to quadrant 3, that again is the same 180 degrees. So that's why they didn't tell us whether to go clockwise or anti-clockwise because, yeah, regardless of which way you go, you end up in the same quadrant. So what I'm trying to tell you here, we are going to end up the final one, M, the rotated diagram is going to end up here. Okay. If they said instead like 270 degrees or 90 degrees, they had to tell us whether to go clockwise or anti-clockwise because if they said 270, if you go clockwise, you end up here, right? Because 270 clockwise, here's 90, here's 180, here's 170. That's clockwise. And instead, if it was anti-clockwise, low, here be 90, here be 180, and here be 270. So they would have had to tell us whether to go clockwise or anti-clockwise because 270 could be two different quadrants depending on which direction you go. Okay. So the only ones that will land on the same exact is 180 and 360 will land back exactly where the diagram is. So how is this diagram going to look when it rotates? I'll show you all the process, okay? I'm going to take it, I think I'll do it both ways just to show you all, right? If we go from here to here first, the diagram is going to just change slightly. So what is going to happen is, I hope you're following how I'm going to show this, right? So this side would be, and as you can see, it's like 1 unit away from the axis, right? So 1 unit away from the axis, which will be from around here to here. It measures like 3 boxes, right? 1, 2, 3, yeah. This side will come there, right? This other slant side will come, let's make sure, like this. Okay, no. I do it a little off, like this. Okay. Um, this other side, this one, will end up like this. And this one, of course, that just closes in the diagram. So the diagram just turns, oh my, slightly, pretty much. But that's not what they wanted. They wanted 180 degrees. So then I have to, from here, I have to turn it over here. Okay, so what is going to happen using the same color coordination? I am starting with the purple line first. This purple line here, make sure it's the same distance. It's from the axis. We'll come here. Okay. The green line will now be facing downwards like this. The brown one is going to be crosshair like that. And the red will close on the diagram like this. So that's where it will be, and that's how it will look when we rotate it, right? Even if we were going the other way around, we'll still end up with it the same way anyways. But I said I was still sure, right? So if instead of me going that way, I wanted to do it from the clockwise direction, where were the red? Okay, let me start with the pink. To me, I think the pink one or purple. Yes, pink, not purple, sorry. The pink one is the easiest because based on what this is, just let me see. It's not really the easiest, but we're going this way. If we're going clockwise, uh, this pink line, let me just make sure. If we're going clockwise, yeah, it will turn this way. So the line is like turning, right? It's making a turn. Each of the lines are just turning. That simply was good. It's just making a 90-degree turn from one quadrant to the next. So that means the green line, the green one will be down here. I have to watch it like so close to figure this thing out, right? The green one will end up here. So it will turn from being like there to going flat. And where's the next one? So we have it like that. So that means the wrong, okay, the wrong would be wrong. Okay, the wrong would be, oh, looking like I'm doing something a little off there just now. The wrong would be like here, right? So it goes from here to slanting the other way. And the red would be this way. So all what just happened here, the diagram just rotate this way. It just like turn a bit. So, and then of course when we reach on this side, it turn from here to here. Okay. Now to really get this, you have to practice, okay? But rotation just means it's each side is turning 90 degrees at a time from one quadrant to the next. But even for this sketch diagram I have, you don't need the extra diagram. You could do this to go from one quadrant to the next to the other until you reach where you need to go. But the diagram you would leave is the one they said to label as M, which is the rotated 180 degrees diagram. Anything else, you just get rid of it. So, if you all have any questions before I move on and do another question, ask your questions. If no, then let's continue. I'm clearing the screen.